Proud as a peacock and strutting her stuff, locomotive number 482 began her new life on May 2nd, 1992, as she pulled the world-famous Silverton train out of Durango, Colorado at 8:30 a.m. sharp. It was a long time since this locomotive looked this brilliant. Over 33 years, in fact. You see, she ended her first life on the narrow gauge with the Denver and Rio Grande Western Railroad in April of 1959. At that time, business on the narrow gauge just wasn't what it had been in the past. And instead of making expensive routine repairs to 482's boiler, the Rio Grande just stored her away in the Alamosa, Colorado yards. In 1970, the rusting engine was towed, dead, to Chama, New Mexico, when a portion of the last remaining narrow gauge empire in America was sold to the states of Colorado and New Mexico. But to the Coombers and Toltec Scenic Railway, the 482 was also too far gone to rebuild. But 21 years later, men with a vision had a plan. The management of the Durango and Silverton Narrow Gauge Railroad traded a larger operating locomotive, number 497, to the C&TS for what was left of the old 482. Since the rails between Chama and Durango had long been torn up, number 482 left Chama on a lowboy truck and arrived in Durango on October 9th, 1991. The locomotive, which hadn't been in Durango for over 3 decades, was rolled back onto familiar rails. What was left of this gallant lady was affectionately shoved into one stall of the roundhouse to begin her rebirth of a locomotive. Now, there's more to rebuilding a locomotive than meets the eye. And in the case of old number 482, there was a lot more. The locomotive hadn't run in over 30 years, and the elements had taken their toll. Once the locomotive was moved to a stall in the D&SNG's roundhouse, the shop forces had their work cut out for them. This roundhouse and shop, by the way, is one of the most modern and complete steam locomotive repair facilities in the world. Here they maintain a complete stable of 6 operating steam locomotives. And in addition, they can machine and even fabricate many of the parts it takes to keep these wonderful machines running smoothly and dependably. A locomotive has thousands and thousands of parts, and all of these had to be removed, inspected, and rebuilt as needed before the 482 could again safely return to the narrow gauge rails. Many parts had already been removed by the engine's previous owners, but there was still plenty of locomotive and tender to work on, over 119 tons of it, in fact. Of course, before you can put a locomotive back together, you have to take it apart, and that's what the shop forces proceeded to do by removing the remaining outside accessories, or appurtenances as they are called, the piping, the main air reservoirs, and the like. The 482 was then jacked up, and the spring rigging that the locomotive rides on was unlaced. A dolly truck was put under the rear to support the weight. The side rods, which transfer the back and forth power of the steam pistons to the wheels, were removed and sent to the machine shop to be bored and have their bushings renewed. The heaviest of these rods weighs in excess of 500 pounds on this locomotive, known in railroad classification circles as a K36, the K standing for Mikado class, or 282 wheel arrangement, and the 36 representing 36,000 pounds of tractive effort. All 8 drive wheels were carefully lowered into the drop pit. The wheels were then raised out of the drop pit and sent to the machine shop for cleaning and inspection. The driver boxes, which are located between the outside counterbalances and the wheels, were removed from the journals, and the old babbitt melted off the sides of the boxes. New crown brasses were installed and bored to the size of the journals. Crown brasses are the brass bearings for the locomotive drive wheels. Also, new babbitt was poured and machined for the correct lateral conditions of the working locomotive. New grease cellar boxes were fabricated and repacked with grease. Grease cellars are boxes that hold the brick grease, which lubricates the locomotive journals. Everything was reassembled onto the journals, properly fit and checked. The Durango and Silverton narrow gauge railroad has the capacity to do a lot of things you just won't find in most other machine shops anywhere in this world. And this includes steam locomotive driver work. The counterbalances were pressed off their drivers with the railroad's 600-ton wheel press, specially designed and built by the D&SNG for this purpose. The hub liners between the counterbalances and wheels were repaired, the journals trued, and the number 1 axle was renewed on the railroad's 24-inch lathe. The tires were recontoured, and once all the pieces were reassembled, the crank pins were quartered on the Durango shop's quartering machine. This, by the way, is one of only 2 machines we know of capable of doing this in existence in America. It was brought to Colorado by the D&SNG from South Africa, after having originally been built in England. Crank pin quartering is essential on a steam locomotive. The term quartering is used because for proper operation, crank pins are set exactly 90 degrees apart, or 1/4 of a turn from right to left sides. Typically, right-hand crank pins lead left-hand pins. The D&SNG's quartering machine will hold up to an 88-inch diameter driver and will hold tolerances within 1½ minutes of 1 degree, or about 5/1000ths of an inch. Both narrow gauge and standard gauge drivers can be accommodated in this machine. Another thing you don't see every day is a ring of fire. Although unnoticeable, locomotives have steel tires that fit onto the driver wheels. This device heats the steel driver tires, which expands them. The tires are then set onto the driver wheel centers and allowed to cool and shrink tight onto the wheel. Meanwhile, the entire locomotive has been sandblasted inside and out. The largest and the heaviest single part of a steam locomotive is the boiler. It's here that water is heated and turned to live steam at a pressure of up to 195 pounds per square inch in this locomotive. The first thing to be taken apart was the smoke box, with the removal of the petticoat pipe, so named because it's a funnel-shaped object, sort of like a woman's petticoat. The nozzle and blower ring and the superheater units were also removed. The superheater in a steam boiler does just what the name implies. It superheats the saturated steam to make it more efficient. Then the 5½ inch flues and the 2¼ inch tubes were removed by being cut off at the firebox end of the boiler and taken out through the smoke box. The throttle valve, which sits inside the rear dome on the locomotive, was disassembled. All the seats were reground and the entire linkage rebuilt. After being reassembled, the lift and the movement on the quadrant were checked. Since the throttle is what provides steam to the pistons, it's important that all the pieces fit together real well. One very important part of the boiler that most people never see is the firebox. Like the name says, it's a box, and it hangs inside the boiler toward the back. Between the firebox and the front of the boiler at the smoke box are the flues and tubes. The hot gases from the coal fire travel through these before they're vented out the smokestack. Every few years, the flues and tubes have to be replaced, and that's an interesting job in itself. To replace all 30 flues and all 137 tubes in a K36 type locomotive requires the diligent work of several men for a total of around 800 working hours. The interior of a boiler without its flues and tubes is really nothing more than a long barrel with perforated ends. One can see the inside of the front flue sheet and the front boiler braces. The pipe on top is known as the dry pipe. This pipe carries steam from the throttle to the superheater header. But before new tubes and flues could be installed, the sheets of metal at either end of the boiler had to be prepared. In the case of putting in an entirely new flue sheet, the metal has to be carefully cut and shaped. And the holes for the tubes and flues have to be precisely bored and reamed. Swedging the flues is one of the more interesting, if not noisy, parts of boiler work. Swedging is the tapering of a flue end so that it will fit into the hole in the rear flue sheet. Once the flues are swedged and annealed, they are installed into the boiler. The necessary copper ferrules are applied in the smoke box end, and rolling, beating, and welding then take place. To do this to the specifications required by safety standards is another art the Durango and Silverton folks are experts at. To hold the firebox in place in the boiler, stay bolts are used. There are two types, rigid and flexible. Rigid stay bolts are much like long rivets. They're typically threaded into the outside boiler shell and inside firebox sheets and riveted over on both ends. Flexible stay bolts serve the same purpose, but they're threaded and riveted only on the firebox sheets. All of the 1,024 stay bolts on number 482 undergo a visual and a hammer test. After all the interior boiler work is completed, the dome lid is set into place. This removable disc, made of 1-inch thick steel plate, allows the only access into the interior of the boiler. With it bolted down securely in place, the boiler is now a pressure vessel ready to test. This is done hydrostatically by pumping the boiler full of water above its maximum allowable working pressure. Water is used as opposed to air or steam so that any leaks can be readily seen. Now that the heart of the locomotive has proven itself, it's time to add to it. The front end assembly in the smoke box is put back together. Then the smoke box door is bolted tight. To insulate the boiler, lagging is used. It's applied in blocks and wired into place from 1.5 to 2 inches thick. And the firebox area is covered with an insulating cement. Then the part you see on the boiler, the jacket, is applied. It's simply sheet metal, which holds the lagging in place and protects it from damage. Now we have a fairly complete locomotive, but we still need something for it to ride on and make it go. The drivers are put back after the binders are removed. Binders are the bottom portion of the frame, directly beneath the drivers. Looking through the frame pedestal jaws, one can see the binders being removed. Special care has to be taken to make sure the drive wheels are parallel with the locomotive frame, as well as the exact distance apart, so the motion of all the moving parts is synchronized. Brass shims, called shoes and wedges, are used to locate the driver boxes in exactly the proper position between the frame pedestal jaws. This process is called layout of shoes and wedges, and it has to be done with great care so that there's harmonious movement of all the driving and running gear. After the drivers are reinstalled, the driver springs are set into place on their saddles, the spring rigging relaced, and the locomotive lowered back down onto its suspension. There's been plenty of other work going on. The steam-driven air compressor has been rebuilt. It's known as a Westinghouse 8.5-inch cross-compound air compressor. Compressed air is stored from the compressor in tanks that sit horizontally along both sides of the locomotive. These tanks are called main reservoirs and supply air for things like the bell and the firebox door opener, as well as, of course, the air brakes. The mechanical lubricator is installed. This is actuated by the movement of the valve motion, and it lubricates the valves, the cylinders, and the flange oilers. Then there's the hydrostatic lubricator, which mixes oil with the steam used to drive the air compressor. You gotta have electricity to run the headlight, the backup light, and the cab lights. And this neat little steam-driven power plant is called the dynamo. It's a steam-powered turbine which generates enough 24-volt DC to power a headlight, which can be seen over 2 miles away in broad daylight. If you're going to make steam in the boiler, you've got to have water. And to get the water from in the tender tank up to 195 pounds of pressure inside the boiler, an injector or inspirator is used. There's one on each side of the locomotive, and they use the Venturi principle. Next, the gauges are installed. A steam gauge to determine boiler pressure, and air gauges that give the engineer important information: main reservoir pressure, brake pipe pressure, independent and straight air pressures. Remember, air operates the brakes. Locomotive brakes are set by admitting compressed air into the brake cylinders, and train brakes are set by a reduction of air pressure, sort of like the system used in 18-wheelers on the highway. The two sets of brakes are operated from different valves by the engineer in the cab. The sand dome is put back on top of the boiler. That's the forward dome, and it's filled with sand to be used for traction under the drive wheels. The engineer controls the flow of sand from the cab. The main fountain is used to provide steam to operate the various appurtenances on the locomotive, such as the injectors, the air compressor, the dynamo, the hydrostatic lubricator, the blower, and so on. The fire doors are installed. These are butterfly-type doors that allow the firemen to shovel coal into the fire through the rear portion or backhead of the boiler. In order to let in as little cold air from the outside as possible, they're air-operated by a foot pedal on the cab floor. There are plenty of cab fixtures, steam lines, air lines, and the water column, water glasses, gauge cocks, and so on to keep the engine men busy. And we can't forget the woodwork, the windows, and the doors. It was entirely renewed by the D&SNG carpenters from the car shop. They put in new window channels and sashes, new cab doors, and even brand new seats and armrests. On the outside of the boiler, the bell and whistle and safety valves were rebuilt, and dozens of feet of piping had to be reinstalled. Air and steam lines also run under the lagging and jacket for use on the locomotive sanders and to heat the mechanical lubricator oil. One of the first items to be taken down is one of the last to go up, the side rods. Now that the work has been done on them in the machine shop, they're carefully reinstalled, one at a time. The side rods that go from wheel to wheel transfer the engine's power to all other wheels from the main drivers, and power is supplied to the crank pins on the main drivers from the main rod on each side of the engine. The main rods are connected through the crossheads to the piston rods, which come out of each cylinder. Just above the cylinder is the valve. It's a smaller cylinder which disperses and regulates the amount of steam going into the cylinders. The linkage which makes the valve function is reinstalled. All the motion was removed and cleaned and inspected. The radius rod was lengthened and the combination rods straightened. The valve links were reground to radius, and the link blocks were renewed, as were all the pins and bushings. Then the valve crossheads were remachined. The valve motion is controlled by the wheels going around, and the amount of effect it has on the operation of the locomotive is controlled by the engineer through the use of the reverse lever, or the Johnson bar. Valve timing is checked and adjusted to assure that valve events occur according to design. Each valve must admit equal amounts of steam to both pistons on both sides of the pistons at the correct intervals. On the roundhouse tender track, the guys have been working on the tender, which rides directly behind the locomotive and carries some 8 tons of coal and 5,000 gallons of water. New wooden decking was installed, which the tank and coal bin sit on. The wheel trucks and the air brake system were reworked, and the whole tender received a fresh new coat of paint and a brand new proud name, Durango and Silverton. The locomotive and tender were then hooked together by use of the drawbars and drawbar pins, and the air lines were connected. With a new coat of gloss black on the locomotive and the number boldly stenciled thereon, a fire was lit inside the firebox for the first time in over 33 years. Over the next several hours, the boiler pressure climbed, and finally, under her own power, the rebuilt number 482 slowly steamed out of her roundhouse stall into the bright Colorado sunlight. A few final adjustments here and there, such as setting the safety valves, or pops as they are called, atop the steam dome, and she was ready for a long and productive career, running through the beautiful Rocky Mountains of southwestern Colorado. And there you have it, folks, the rebirth of a locomotive. Number 482, as she proudly displays her beauty, a truly living and breathing product, reborn by conscientious, hard-working, devoted employees of the Durango and Silverton Narrow Gauge Railroad, who overcame agonies and frustrations and applied tender, loving care to ensure that this locomotive once again was able to take her place in history as she struts her stuff pulling the Silverton train through the spectacular Animas Canyon. We proudly credit and dedicate this film to the men who helped in her rebirth and who are equally proud to take their place in history with America's legend, the Durango and Silverton Narrow Gauge Railroad.